All right, so you've been digging into this whole MLOps thing, right? And it's like everyone's talking about it, but you're not just looking for buzzwords.
Yes.
You want like the real deal. You want to know what it's really all about.
Yeah.
So you've come to the right place. We're going to dive deep into all those articles you've got, the expert interviews, all that stuff to give you like a supercharged MLOps knowledge boost.
I like it. Knowledge boost.
Yeah, without the information overload.
Okay, I'm ready.
I think what I'm always struck by is how the research frames MLOps.
Yeah.
Like, it's not just a trendy term, you know?
No, it really is like a whole rethinking.
Yeah.
It's a paradigm shift.
Yeah, it's not just about throwing it around.
Yeah.
It's how we approach machine learning, right?
It is.
It's bigger than just getting the best score, like, in your Jupyter notebook.
Totally, like building a super accurate model, being like, mic drop, I'm done.
Exactly. It's about making it work in the real world, reliably.
At scale.
At scale, yeah. Like
every day.
Yeah.
Think like.
Every day.
Self-driving cars, fraud detection systems.
Yeah.
That actually stop the bad guys.
Personalized medicine.
That's the promise of MLOps. You know?
Yeah, that's a huge GE leap from just tweaking parameters on your laptop.
It is.
As a data scientist.
Yeah.
Where do we even begin to bridge that gap, right?
So I think the research actually breaks this down pretty well.
Okay.
It shows how MLOps is really at this intersection of three really huge fields.
Okay.
You've got machine learning, obviously, software engineering, especially DevOps, and data engineering.
Got it. Yeah, it's like all three of those things coming together.
Yeah, it's that synergy.
Yeah.
That makes it so powerful.
So it's not just about the algorithm, it's about the whole ecosystem around it,
It's a whole ecosystem.
But let's be honest, MLOps sounds kind of intimidating, right?
A little bit, yeah.
What are the core principles that make it work?
So the research does an awesome job of outlining these.
Yeah.
It's not just a list of jargon.
Yeah.
They're solutions to these really challenging problems in making ML work reliably.
Yeah.
In the real world.
Okay, so give me an example. Like, what's one that'll really stick?
Okay, let's take versioning.
Okay.
It might sound kind of boring.
Yeah.
But imagine this. You've trained your model. It's performing well.
Okay.
Then, boom,
Yeah.
new data comes in.
Right.
Or there's a bug in your code.
Oh, yeah.
Without proper versioning, it's like a nightmare to figure out what changed when and who did it.
Right.
It's like trying to edit a document without track changes.
Oh, my God.
Total chaos.
Yeah, total chaos.
With MLOps, versioning is like essential.
Yeah, it's not just good practice. It's like you need this to stay sane.
You need it. Yeah, right.
Right.
Yeah.
So, okay, I'm starting to see why this stuff is important. What about this whole automation thing?
Oh, yeah, but think about it.
Yeah.
Like manual processes.
Yeah.
They're slow. They're prone to errors.
Right.
And they just don't scale.
Yeah.
When you're talking about ML,
yeah.
Imagine retraining and redeploying a model.
Right.
Every time new data comes in.
Oh, yeah.
Forget it. You'd be working 24/7.
Yeah.
You wouldn't have time for anything else.
Yeah.
Automation in MLOps streamlines that whole workflow.
Okay.
From the data prep
to
the training, testing, deployment, even monitoring.
Right.
So you can focus on the cool stuff.
Okay.
The problem solving.
Yeah, so you can use your brain for, like, the creative stuff.
Yeah, not the boring, repetitive stuff.
Yeah, not the boring, repetitive stuff.
Exactly.
So automation is about efficiency and freeing up brain power for, like, the cool stuff.
Yeah.
So how do we actually go from these principles to, like, an actual system?
And that's where the research gets really practical.
Okay.
It breaks down the nuts and bolts of building a robust system.
So we're talking tools, platforms, the whole shebang.
Exactly. We're talking about things like continuous integration and continuous delivery.
Okay.
CI/CD pipelines.
Yeah, CI/CD, those automate.
They do.
Building, testing, deploying models.
Think of it like an assembly line for your models.
Okay.
So everything is built and shipped consistently.
And it's not just about saving time and effort, right? It's also about reducing the risk of errors.
Huge risk reduction.
Because if you're doing it manually, you're going to make mistakes.
Oh, for sure.
And you want to make sure that everything's tested.
Totally.
Right.
Yeah.
That's a huge relief.
It is, especially
when things are changing all the time.
When you have a complex model, constantly evolving data.
Yeah.
You want that safety net.
Yeah, and the research mentions some of the popular tools out there, like...
Yeah, so you got Jenkins, GitHub Actions.
Yeah, okay, so we've got our code and models moving through these automated pipelines, right?
Yeah.
But machine learning workflows, I mean...
Oh, yeah?
They can be pretty complex.
They are.
There's a lot of steps, dependencies. How do we manage all that?
That's where workflow orchestration comes in.
Okay.
These tools let you define and automate all those steps.
Okay.
They specify the order and the dependencies.
Yeah.
Imagine a complex recipe.
Okay.
The orchestration tool is like the master chef.
Oh, I like that.
Making sure each step happens in the right order.
Okay.
The right time.
So instead of manually managing each step, we define the whole workflow.
You got it.
Up front.
And the tool handles it.
And the tool's like, I got this. Exactly.
I could do it.
It does it all for you.
That's pretty cool.
It is. And it gives you visualization and monitoring, too.
Oh, wow.
So you can track progress, see bottlenecks, and fix problems quickly. So it helps you prevent things from turning into a disaster.
Exactly.
What are some of the
tools mentioned? The batchy airflow, kubeflow pipelines, Azure ML pipelines.
Yeah, okay. So those are all tools for orchestrating.
Those are your big players.
Okay.
Yeah.
And what about the data itself?
Right.
We talked about feature stores.
Yeah.
Like our pantry for data.
Yeah.
But how do they actually work in practice?
Yeah, so the research digs into this a little bit deeper.
Yep.
You have online feature stores.
Yeah.
Which give you low latency access to features for real-time predictions.
Okay.
This is crucial for stuff like fraud detection, personalized recommendations.
Where you need the prediction like that second.
You need it right away.
Yeah.
Yeah.
Okay, and what about offline feature stores?
Offline feature stores are great for batch predictions.
Okay.
Or model training.
Okay.
Where latency isn't as important.
So it's more for, like...
You can store a ton of historical features.
Yeah, like large batch jobs or something.
Exactly.
Where you don't need it.
It's all about the use case.
Right then and there, yeah.
Yeah.
Okay, so you choose the type of feature store based on what you're trying to do.
Based on your needs.
But even then, managing features, it can get kind of hairy, right?
It can.
Like you have multiple teams, different models.
Yeah.
Maybe using different versions of the same features.
It's a challenge for sure.
Yeah, that sounds like a recipe for
trouble.
Trouble.
Yeah.
What are some strategies to make sure everyone's on the same page?
So, good MLOps practices include defining clear feature specifications.
Okay.
Version control for those definitions.
Yeah.
And automated testing to catch those inconsistencies
early on.
Whenever
it becomes a problem, yeah.
Some feature stores even have built-in mechanisms
nice.
to help manage these things.
Okay, so there are tools to help us out.
Yeah.
Okay, good.
Yeah.
So we've talked about the data, the workflow. Right. What about the infrastructure for training these models?
Right.
Because
especially like deep learning, big data.
Deep learning, tons of data.
You need some horsepower.
Yeah, you need a lot of computing power.
You do.
My old laptop's not going to cut it, right?
Maybe for small experiments.
Okay, yeah.
But for serious development, you're going to need more.
Okay, so what do we do?
Cloud platforms are a popular option. They offer scalable, on-demand computing resources just for this purpose.
Yeah, so it's more cost-effective than...
Way more.
Yeah, buying a bunch of expensive hardware.
Exactly.
That you might not even use.
And they're already set up.
All the time.
With all the tools and stuff.
And they have pre-configured environments and tools.
Yeah, it's much easier.
So you can just be like, okay, I'm ready to go. Here's my code.
Exactly.
Cool. That makes a lot of sense.
And the research mentions some popular ones.
Okay.
AWS SageMaker.
Yeah.
Azure ML. Google Vertex AI.
Cool. So lots of options out there.
Yeah.
For training and deploying.
That's right.
Okay, so let's say we've trained our model.
Okay.
It's performing well. But we need a safe place to store it.
Yes.
Right.
Before we unleash it on the world.
Yeah. We need to be able to manage different versions.
Totally.
Go back to a previous version if something goes wrong.
You're thinking like an MLOps Pro.
Okay, good.
That's where model registries come in.
Okay.
They're like central repositories.
Okay.
For storing and managing your models.
Right, so it's not just the model files themselves, right? It's like all the...
you got metadata, dependencies, performance metrics.
Yeah.
It's like a library for your models.
Okay.
But with all the extra bells and whistles.
Okay, so you can track everything.
You can.
You know what's in there. You know how it works.
And this is so important.
For collaboration, reproducibility, maintaining a history of your models.
So you don't lose track of what you've done.
Exactly.
And the research mentions a few popular model registries like...
MLflow, AWS SageMaker Model Registry, Azure ML Model Registry.
So again, lots of options out there.
Yeah, you got choices.
And they all work with the other MLOps tools, right?
They're all designed to play nicely together.
Okay, so our model's tucked away.
It is.
Safe and sound in the registry.
All documented.
All documented.
Ready to go.
Now, the moment of truth.
Deployment.
How do we take it from this cozy little registry and unleash it on the world?
So this is where your model really comes to life.
Yeah.
And there's different ways to do it.
Okay, like what?
One way is batch prediction.
Okay.
Where you use your model to make predictions on a large batch of data.
Okay.
Offline.
Offline. So you're not doing it like right that second, not in real time.
You're doing a whole bunch of predictions at once.
Exactly.
Oh, yeah.
This is good for stuff like product recommendations, customer segmentation, things like that.
Okay, so you can process a bunch of data, get the predictions, and then use those for some other task.
That's right.
Wow.
Then you have online prediction.
Okay.
Or real-time inference.
Okay.
This is where your model needs to be.
Yeah.
Generating predictions on demand.
Right.
Like super fast.
Yeah, so this is like if you're doing...
Big fraud detection.
Fraud detection, yeah.
Personalized search results.
Or like a voice assistant where they want the answer right away.
Those are perfect examples.
Yeah.
Yeah.
Okay, so how do you...
And this requires different tools and techniques.
Yeah.
You need stuff like containerization.
Okay.
Docker, Kubernetes.
Okay.
To package your model up.
Okay.
As a microservice.
As a microservice. Okay.
And to deploy it.
Can you explain microservices in like simple terms?
Yeah, think of it like a tiny little app that just does one specific thing.
Okay.
In this case, making predictions.
Okay. So instead of one giant app,
you break it down.
You break it up.
Into smaller pieces.
Okay. So it's more manageable.
Exactly.
And it's easier to scale.
And more reliable.
Yeah. Okay, cool.
And there are platforms like Kubeflow serving and TensorFlow serving that make this whole process easier.
Okay, so lots of tools to help us out.
Lots of tools.
All right, so our model's deployed. It's out there making predictions.
Yeah.
Can we relax now?
Not so fast.
Oh, no.
Remember, continuous monitoring.
Right.
We need to keep an eye on things.
Okay, why?
Because things change.
Right, data changes.
Data drifts. New patterns emerge.
Yeah.
And we need to know if our model is still accurate.
Yeah, because the real world doesn't stay static.
It doesn't.
Things are always changing. If our model's making weird predictions, we want to know.
You got it.
So how do we do that?
That's where monitoring tools and platforms come in. They help you collect data, analyze your model's predictions, and spot issues like concept drift.
Concept drift? What's that?
That's when the relationship between the input and output changes over time.
So like what worked yesterday might not work today.
Exactly.
So it's basically like an early warning system.
For our models.
It's like a smoke detector for your ML.
Okay, and some of these platforms, they can even
automatically respond.
Oh, wow.
Like retrain the model or roll back to a previous version.
So it's not just about monitoring. It's about
taking action.
Yeah.
To keep things running smoothly.
So it's this constant
continuous feedback loop that keeps our models
accurate,
relevant,
and accurate. Yeah, so MLOps is not a one-time thing. No, it's ongoing.
It's an ongoing process.
It is.
Okay, so what are some popular monitoring tools?
Some popular ones are Prometheus, Grafana, and the ELK stack.
ELK stack. What's ELK stand for?
That's Elasticsearch.
Okay.
Logstash.
Yeah.
And Kibana.
And they track
all kinds of metrics.
Yeah.
Model performance, data quality, infrastructure health.
So they're watching everything.
You're keeping an eye on things for you.
This has been amazing. We've really gone through.
Yeah, we've covered a lot.
Yeah, a lot of the tools and technologies that power MLOps.
From pipelines to feature stores. Yeah. Model registries. Yeah. It's a whole ecosystem.
It is, and it's constantly evolving too, right?
It is.
Like there's new tools coming out all the time.
All the time.
But the underlying principles
stay the same.
Yeah, they're like the foundation.
The foundation.
Yeah. Automation.
Collaboration. Continuous improvement.
And a focus on
value.
Yeah, delivering actual
real world value.
Not just like
not just theory.
Theoretical numbers.
Yeah.
Okay, so we've covered a lot of the technology behind MLOps.
We have.
But what about the people? Like,
who's building these systems?
Who's building them? Who's managing them? Yeah.
Yeah.
We'll explore that.
That's next.
In part 2.
Stay tuned.
Welcome back. So, last time, we kind of set the stage, right?
Yeah, we did.
We talked about all those fundamental MLOps principles. and the challenges that they solve. But let's get down to brass tacks here. Let's get our hands dirty.
I like it.
What are the
Let's open up that MLOps toolbox.
The tools and technologies that actually make this whole thing work in the real world.
So remember all that stuff about automation?
Yeah.
And continuous delivery?
CI/CD.
CI/CD?
Yeah. That's where these tools come in.
That's where the tools come in.
But like beyond just the definition,
right?
How do they actually work in an MLOps context?
So think of CI/CD tools as the assembly line.
Okay.
For your machine learning models.
Okay.
They automate the entire process of building, testing, and deploying those models.
Okay, so instead of me
every
manually running each step,
run smoothly.
I have this system that's
consistently.
Yeah, that does it for me.
Exactly.
Triggered by like code changes,
new data.
Or new data, yeah. Okay.
It just takes care of it for you.
So it's not just saving me time and effort, it's also like reducing the risk of errors, right?
It's huge, yeah.
Because
you don't want to be doing this manually.
Yeah, I'm going to mess things up if I do it manually.
You're going to make mistakes. And you want to be sure.
And I want to make sure everything's tested.
That everything's tested and meets your quality standards.
Yeah, and it meets quality standards, yeah.
Yeah.
Especially when you're dealing with such complex systems.
Complex models.
Yeah.
Constantly evolving data.
Data that's always changing, yeah.
Yeah.
Okay, so the research mentions some popular ones like...
Yeah, Jenkins, GitHub Actions.
Okay.
Those are widely used.
Yeah, and those are like specifically designed for MLOps?
They are. They have great integrations with other ML tools.
Okay, so we've got our code and our models moving through these automated pipelines.
Right.
But machine learning workflows can be pretty complex, right?
They can, yeah.
There's all these different steps, dependencies.
Multiple steps.
How do we manage all that?
That's where workflow orchestration tools come in.
Okay.
These tools give you a way to define and automate the steps of your ML pipeline.
All right.
That specify the order,
the
dependencies. Imagine a complex recipe like with baking.
Okay, yeah.
The orchestration tool is like your master chef.
Oh, I like that analogy.
It makes sure each step happens in the right order at the right time.
Okay, so instead of me, like...
So you don't have to manually
manage
manage every single step.
Yeah.
You can define the workflow up front.
And then just let it run.
And let the tool handle it.
Yeah.
And it does a lot more than just that. It gives you visualization, monitoring. So you can track the progress, identify any bottlenecks, troubleshoot any issues that come up quickly.
So it helps you keep things from like...
It keeps things running smoothly.
Yeah, from becoming a big mess.
Exactly.
Okay, and the research mentions a few of these tools, like...
So you got Apache Airflow, Kubeflow pipelines, Azure ML pipelines.
And those are all like popular tools.
Those are the big players.
Okay. All right, well, what about the data itself?
The data.
We talked about feature stores, right?
Yeah, we did.
Like our pantry for data.
Our pantry.
But like, how do they actually work in practice?
Yeah, so the research goes a little deeper.
Yeah.
There's different types of feature stores.
Okay.
You got online feature stores, which give you that low latency access that you need for real-time predictions.
Okay.
Like fraud detection.
Yeah, where you need the prediction.
You need it instantly.
Like right now.
Yeah.
Okay, and what about offline feature stores?
Offline feature stores are great for batch predictions or model training.
Yeah.
Where latency isn't as critical.
So that's for those use cases where you don't need...
Yeah, if you don't need...
Like a super fast response.
Immediate response.
Yeah.
Yeah.
Okay, so you choose the type of feature store based on your needs.
Based on your needs.
Yeah, what you're trying to do.
Exactly.
But regardless of what type of feature store you use, managing features, it can get complex.
It can get tricky.
Yeah.
Especially when you have multiple teams.
Right, because you've got
multiple models.
Different models, different teams.
Potentially using different versions.
Yeah. Of the same feature.
Yeah, right. Of the same features, yeah.
Yeah, that sounds...
It's a recipe for...
Like a recipe for disaster.
Disaster, yeah.
Yeah. What are some strategies to ensure... like everybody's on the same page?
Good MLOps practices include defining clear feature specifications.
Okay.
Using version control for those definitions.
Okay.
And automated testing.
Right.
To catch any inconsistencies early on.
Yeah. Before they become a problem.
Before they become a problem.
Yeah.
Some feature stores even have built-in mechanisms.
Oh.
To help you manage this.
Okay, so there's tools that can help us out.
There are.
Okay, good.
Yeah.
All right, so we've talked about the data. We've talked about the workflow.
Right.
But what about the infrastructure for training?
The infrastructure.
Yeah.
These models.
Especially with...
Because training complex models can...
Deep learning.
Take a lot of computing power.
And large data sets, yeah.
Yeah, especially with deep learning.
Yeah.
Like tons of data. You need some serious horsepower.
Yeah, my old laptop's not going to cut it.
Maybe for small-scale experiments.
There's some scale stuff, yeah.
For serious model development, you're going to need
So what do we do?
More power.
Yeah.
Cloud platforms are a popular option.
Okay.
They offer scalable, on-demand computing resources for model training.
So it's more cost-effective.
Way more cost-effective.
Than buying a bunch of...
Than investing in all that expensive hardware.
Expensive hardware?
Yeah.
That I might only use.
That might just sit there.
Occasionally, yeah.
Exactly.
And cloud platforms also offer...
Pre-configured environment.
Yeah. Tools that simplify.
To simplify the setup.
Yeah.
And management.
So I don't have to be like...
You don't have to worry about...
a sysadmin to set this stuff up.
Exactly.
Cool. That makes a lot of sense.
You can focus on the model.
Yeah.
Not the infrastructure.
And the research mentions some of these platforms like...
Yeah, AWS SageMaker, Azure ML, Google Vertex AI.
Okay. And those are all specifically designed for machine learning.
For ML workloads.
Okay, so we've trained our model.
Okay.
It's performing well.
Yeah.
We're ready to...
Time to unleash it.
Unleash it on the world.
Yeah.
But before we do that...
We need
a place to store it.
A safe place to store it.
Yeah, a safe place to store it.
Yeah.
So we can manage...
different versions.
Different versions.
Go back to a previous version if we need to.
Yeah, if something goes wrong, we want to be able to roll back.
You're thinking like a true MLOps practitioner.
I'm trying.
You're getting it.
Yeah.
So that's where model registries come in.
Okay.
They act as central repositories.
Okay.
For storing and managing your trained models.
So it's not just the model file itself, it's all the information about the model, right?
Metadata.
Yeah.
Dependencies.
Yeah.
Performance metrics.
Okay, so it's like...
Think of it like a library.
A library.
For your models?
Yeah.
But with all the extra features.
With all the extra information.
For versioning, documentation, collaboration.
So you know exactly what you're dealing with.
You got it.
Yeah, and that's crucial for, like...
It's crucial for...
Collaboration, reproducibility.
Collaboration,
right?
reproducibility.
But you're making sure...
Maintaining a history.
Yeah. That you can always... Your models, so you don't lose track of anything.
Yeah. And the research mentions a few popular model registries.
Yeah, like MLflow.
Okay.
AWS SageMaker Model Registry, Azure ML Model Registry.
Okay, so again, lots of options out there.
Lots of options.
And they all integrate with other MLOs tools.
They're designed to play nicely.
Okay, so our model is...
tucked away.
Safe and sound in the registry.
Safe and sound.
All its information.
All documented.
Nicely documented.
Ready to go.
Now the moment of truth. Deployment.
Deployment, how do we actually take it from this registry?
This is where your model comes to life.
And unleash it on the world.
And starts generating real-world value.
Yeah, and there's different ways to do that, right?
There are.
Okay.
Depending on your needs.
What are some of the common...
the deployment scenarios?
One common scenario is batch prediction.
Okay.
Where you use your model to generate predictions on a large batch of data.
Okay.
Offline.
Offline, so you're not doing it in real time.
Not real time. You're processing a whole bunch.
A whole bunch of data at once.
Of data. And then...
This is suitable for tasks.
Yeah.
Like generating product recommendations.
Okay.
Or segmenting customers.
Where you don't need...
the
prediction, like, right, that second.
That instant feedback?
Yeah.
Yeah.
Okay, so you can process a bunch of data. Get the predictions. And then use those for something else.
Right. Okay, what else?
Then you have online prediction, also known as real-time inference.
Real-time, okay.
This is where your model needs to be.
Yeah.
Generating predictions on demand.
Right.
With very low latency.
So that's for things like...
correct.
Fraud detection, personalized search results.
Fraud detection.
Yeah.
Personalized search.
Like a voice assistant.
Voice assistants, exactly. Where you need that.
Those are perfect examples.
Yeah. Instant response.
Yeah.
Okay.
And deploying models for real-time inference.
Yeah.
Requires different tools and techniques.
Okay.
You often need to use containerization technologies.
Like what?
Like Docker.
Okay.
Kubernetes.
Okay.
To package your model as a microservice.
Microservice.
And deploy it in a scalable, fault-tolerant way.
Okay, can you explain microservices?
Okay.
Like in simple terms.
Think of it like a small, self-contained application that performs a specific function. In this case, generating predictions.
Okay, so instead of having one giant application,
exactly,
it does everything.
You break it down.
You break it down.
Into smaller, more manageable pieces.
Okay, so it's easier to
manage. Easier to scale.
Yeah.
More fault tolerant.
More fault tolerant. Okay.
Yeah.
So that makes a lot of sense.
And there are platforms like Kubeflow serving and TensorFlow serving that simplify this process.
That make this whole process easier.
Way easier.
Okay, cool. So lots of tools to help us out.
Lots of tools.
All right, so our model's deployed.
Okay, it's out there.
It's out there in the wild.
Generating predictions.
Making predictions.
Can we finally relax?
Can we just, like, kick back and relax? Yeah.
Not so fast.
Oh, no.
Remember that principle of continuous monitoring?
Oh, yeah.
We got to keep an eye on things.
Why?
Things change.
Yeah. Data changes.
Data drifts. New patterns emerge.
Yeah.
We need to know if our model is still accurate.
Right, because what worked yesterday might not work today.
Exactly.
Yeah, because the real world.
The real world's dynamic.
It's dynamic.
Things are constantly changing.
Yeah, it's always changing.
And if our model starts making weird predictions...
Yeah, we want to know.
We need to know.
Yeah, we want to know.
So how do we do that?
Yeah, how do we do that?
Monitoring tools and platforms.
Okay.
They allow you to collect and analyze data about your model's predictions and spot issues.
Okay.
Like concept drift.
Concept drift, what's that?
That's when the relationship between input and output changes over time.
So it's basically like the relationship between those two things changes.
Exactly.
Okay. It's like a...
So these tools are like our early warning system.
Our early warning system.
Yeah.
It's like a smoke detector.
Yeah.
For your ML.
Okay.
And some of these platforms can even automatically respond
to those alerts.
Okay.
It's like retraining the model.
Okay.
Or rolling back to a previous version.
Okay, so it's not just about monitoring.
No, it's about
taking action
to
fix...
keep things running smoothly.
The problems.
Yeah, so it's this...
It's continuous feedback loop.
Yeah, this feedback loop.
That keeps your models relevant, accurate.
Accurate over time.
Over time.
Yeah, because if you just deploy it...
It's not a one-time thing.
And forget about it. Yeah.
It's ongoing.
Yeah, it's this ongoing process.
It is.
Okay, so what are some popular monitoring tools?
Some popular ones are Prometheus, Grafana, and the ELK stack.
ELK stack. What's the ELK stand for?
That stands for Elasticsearch,
okay,
Logstash, and Kibana.
Okay, and these tools can track all sorts of things.
They can track all kinds of metrics.
Yeah,
like model performance,
data quality, infrastructure health.
So they're keeping an eye on...
They're watching everything.
Everything for us.
Exactly.
Wow, this has been an incredible journey.
Yeah, we've covered a lot.
Through, like, MLOps,
orchestration,
future stores, model registries,
pipelines and orchestration,
and the whole ecosystem.
To feature stores and model registries.
Of tools and technologies.
This is a whole ecosystem designed to make this whole thing work.
Designed to make machine learning more robust.
Yeah, more robust, more reliable.
More impactful.
More impactful. And it's a rapidly evolving field, right?
It is rapidly evolving.
Yeah.
New tools are coming out.
Yeah, all the time.
All the time.
But the underlying principles
stay the same.
Yeah, they were like the foundation.
They are the foundation.
Yeah.
You got automation.
Collaboration. Continuous improvement. And a focus on delivering.
Yeah. And delivering real world value.
Real world.
Not just
theory.
Like theoretical numbers.
Yeah.
Okay, so we've covered a lot of the technology that powers MLOps.
Like technology.
But what about the people?
The people.
Like
who's building these systems?
Yeah, who's building these systems?
Who's managing these systems?
We're managing them, yeah.
Yeah.
We'll delve into that.
That's what's up next.
In part 3, we've talked about the principles, the tech, the whole toolkit. But like with any complex system, it always comes down to the people, right? Like, who are the actual masterminds behind these MLOps systems?
You got it. It really does take a village to raise an AI, or in this case, a well-oiled MLOps system.
Right.
And the research really underscores how it's not about like one brilliant person. It's about a team with diverse skills coming together.
Okay, so like, paint me a picture here. Who are the key players on this MLOps dream team?
All right, so first up, you got to have your data scientists. They're the rock stars.
Yeah.
You know,
Yeah.
The creative minds behind those algorithms.
Right.
They're constantly pushing the boundaries.
So they're the ones with the
of what's possible.
Uh-huh.
Moments. Yeah, they get the math.
Yeah.
The data patterns.
Yeah.
How to translate, like, business problems into these really elegant mathematical solutions.
So they're the ones who, like, find those patterns and are like, oh, we can solve this problem using this approach. Right?
Exactly. They're the innovators, for sure.
Okay, so we've got our data scientists.
Yeah.
But they can't do it alone, right?
No way.
Who else do we need?
You need your data engineers, right?
Okay.
Those are the masters of data pipelines.
Yeah.
And infrastructure.
Okay.
They make sure that data is flowing.
So they're like...
smoothly. Yeah, the plumbers of data.
Yeah, they make sure the data's clean, ready to go.
They're building the data highways.
Yeah.
Keeping the whole system running.
Making sure the right data gets to the right place at the right time.
You got to...
Okay, so we've got our data scientists, we've got our data engineers.
Mm-hmm.
Who else is on this team?
And then you got to have your software engineers, right?
Okay.
The architects and builders of the systems that support this whole thing.
So they're building the actual systems and platform.
Quoting the pipeline.
Yeah.
The workflows.
Yeah.
The deployment platforms.
Oh.
All the essential infrastructure.
Right. So everything runs smoothly.
You got it.
Okay. So we've got our data scientists, our data engineers, our software engineers.
Right.
But you mentioned earlier that MLOps also introduces some new specialized roles.
This is where it gets interesting.
Yeah.
So as MLOps is maturing, we're seeing this rise in these blended roles.
Okay.
One crucial role is the DevOps engineer.
Okay, the DevOps engineer. And they're sort of like
They're the glue.
Yeah, the glue between...
the development and operations, right?
Yeah,
the development and operations teams.
So they're making sure those models actually,
they ensure those seamless transitions.
Out into the real world.
Continuous delivery.
Without breaking everything.
You got it.
Yeah.
They're the automation experts. The infrastructure wizards, making sure the system can handle all those demands.
Of continuous deployment and monitoring,
Exactly.
Okay, so then what about this...
And then
mysterious ML engineer or MLOps engineer
that the research talked about.
Yeah, that the research talked about, yeah.
This is like the ultimate multi-hyphenate.
Okay.
The Swiss Army knife of MLOps.
Okay.
They have this, deep knowledge of machine learning.
Okay.
But also practical software engineering skills.
So they can kind of talk to everybody.
And data engineering skills.
And understand everything.
They can speak the language of all the other teams.
Yeah.
And navigate the complexities of that whole MLOps life cycle.
So they're like the kind of the conductor of this whole orchestra.
Perfect analogy.
Yeah. Making sure.
They're making sure.
Everyone's in sync.
Everyone is in sync.
Yeah.
And the music flows.
Yeah.
And as MLOps gets more mainstream, these folks are going to be in high demand.
Because they have that combination of...
They do. They have the technical expertise.
Yeah, technical.
They got that collaborative spirit, that big picture understanding.
Yeah, to make everything work.
To make it all sing.
Okay, so we have our dream team assembled.
Right.
But even with the best people, there's still those organizational and cultural challenges that your research talked about, right?
It's not always easy for organizations to adapt.
Yeah. What are some of the biggest hurdles?
One of the biggest hurdles.
Yeah.
Is that traditional data science teams often operate in silos.
Right. They're kind of
focused on model accuracy.
Often their own little corner.
Yeah. It's all about
doing their own thing.
Getting that high AUC score.
Right. But not thinking about how it actually fits into the bigger picture.
Exactly. And that's a problem.
Yeah.
Because successful MLOps requires a shift in mindset.
Okay, so how do
it's not just about
that mindset.
Building the best model in isolation.
Right.
It's about building the best system.
Okay.
For delivering value.
Yeah.
With machine learning.
So it's about the whole system, not just one piece of it.
Exactly. You need to break down those silos.
Yeah.
Foster collaboration.
Yeah.
Focus on that end-to-end life cycle.
So it's not just a technical challenge, it's a
people challenge.
People challenge.
Yeah. It's about changing how teams interact.
Yeah, how they work together.
Yeah. Yeah.
And this needs to happen at all levels, right?
It does. It needs to happen.
From
from the top down.
Bottom up.
Bottom up.
Leaders need to set the vision.
Yeah.
Create an environment that supports
collaboration and experimentation.
Yeah.
Individuals need to be open to learning.
Okay.
Working across disciplines.
Yeah.
Embracing that iterative nature.
So it's a journey, not a destination.
It's a journey.
Yeah.
And it sounds like there's a lot of exciting work to be done. Oh, tons in this space.
MLOps is still a relatively young field.
Yeah.
But it's evolving so rapidly.
Yeah.
And if you're passionate about AI,
yeah,
this is an incredible opportunity to be at the forefront of innovation.
Well, this has been fantastic.
Yeah.
I feel like we've really
covered a lot of ground.
Yeah, from the principles to the tools to the people. And the challenges. It's been, I feel like I have a much better understanding.
That's what we like to hear.
Yeah, of what MLOps is all about.
That's what the deep dive is all about, giving you the knowledge and insights to navigate this complex world.
Yeah, and feel empowered.
To actually, go out there and do stuff.
Go explore.
Yeah.
Go learn.
So to our listeners out there, if you're feeling inspired.
Yeah, take the plunge.
Take the plunge.
Dive into MLOps.
Yeah, dive into MLOps.
It's a journey.
Remember, it's a journey.
Continuous learning.
Collaboration.
Pushing the boundaries.
Yeah, and pushing the boundaries of what's possible.
With
AI.
And who knows?
Yeah.
Maybe you'll be the one building.
That
next groundbreaking MLOps system.
The next groundbreaking system.
Solving real-world problems.
Yeah.
Shaping the future of AI.
That's a great note to end on, I think.
I think so, too.
Thanks for joining us on this deep dive.
Yeah, thanks for having me.
Into MLOps.
It's been fun.
Until next time, keep exploring, keep learning.
And keep diving deep.